Audio Jungle. Audio Jungle.
Hello everyone. Now this is the performance subject and it will start from gate 2022. So it is gate 2022. All right. Now this is question number 18. Now the service ceiling of an airplane is the altitude. So basically ceiling we know two types of ceiling in climbing of the aircraft if you see. So two types of ceiling we have. Okay. Two types of the ceiling we have. It is nothing but absolute ceiling and service ceiling. Okay. So now question here, it is related to service ceiling, but you need to remember that absolute ceiling rate of climb value is what? 0. And service ceiling rate of maximum rate of climb value is, you need to remember this, 100 feet per minute. Or this 100 feet per minute also, if you calculate, it is approximate 0.508 meter per second. All right. Now we'll go for the options. At which maximum rate of climb is 100 meter per minute, which is wrong. Beyond which theoretically the airplane cannot sustain level flight. No, this information is given for the absolute ceiling, because at absolute ceiling, this is the one altitude where the rate of climb becomes 0. So uh, at absolute ceiling case, beyond the beyond that altitude, that airplane cannot sustain level flight. That is correct. But here this question is what for the service ceiling. So this option B will also be wrong. At which maximum power is required for flight? No, it is also wrong. At which maximum rate of climb is 100 feet per minute, which is correct answer. So option D is the right answer. All right. Now we will go for this question number 27. Okay. This is again the same gate 2022 question number 27. All right. For international standard atmosphere ISA up to 11 kilometers. So basically from sea level to 11 kilometer, 0 to 11 kilometer. Okay. This is called troposphere. What it is called? Troposphere, just for information. And 11 kilometer to 25 kilometer, you remember, it is called stratosphere. Okay. All right. Now, which of the following statements is or true? It means more than one option also can be correct. Okay, as per given the sentence, if you check, more than one statement also may be correct. Okay, this is called multiple select question. All right. Now, so hydrostatic or aerostatic equation is used. Obviously, if you go for the troposphere, means 0 to 11 kilometer, it is called troposphere. So for troposphere, if you check two governing equation, we always use dp by ds is equal to minus rho g, which is also called hydrostatic in fluid mechanics. You have seen. Okay, dp is equal to minus rho g dh, or p is equal to rho gh. That you know in fluid mechanics we have seen. This is the one governing equation which will be used in troposphere. Second governing equation is for p is equal to rho rt. This is called the ideal gas equation, or perfect gas equation. Okay, so or state equation also sometimes called. So these two equation will be used for the derivation in troposphere, which is from 0 to 11 kilometers. So obviously option A, in this way option A is correct. All right. Temperature lapse rate is taken as 10 to power minus 10 to power minus 2 Kelvin per meter. No, this is wrong, because 0 to 11 kilometer, which is troposphere, and in troposphere temperature lapse rate means dt by dh. Always remember, or dt by, it is also called dt by altitude. So obviously h is the altitude, or sometimes it is also considered as distance l. That meaning is same. It is nothing but lambda, and this value is what given, 6.5. Okay, 6.5 Kelvin per kilometer. This is the fixed value you need to remember for troposphere, I am saying. 6.5 Kelvin per kilometer, or in some places you may have seen this value 0.0065 Kelvin per meter. This is also correct. All right. So this is always remembered here. This is for the troposphere. But what is the lapse rate here? It is given, and obviously this is minus sign. Yes, you need to remember lapse means decrement. So if you from sea level to any altitude or any height, if you go in upward direction, so temperature uh, will be decreasing. Okay, so that's the reason you may have a minus sign. So that's the mean of lapse. Lapse means decrement. So here also minus sign. But what is the exact value? This is the exact value you need to remember. So this value, whatever it is given, it is wrong. So obviously these wrong options. All right. Now we'll go for option C. The sea level condition are taken. Pressure is sea level condition they have given. So pressure, static pressure is 1.01325 10 to the power 5 Pascal, or you can say 101,325 Newton per meter square. So it is, this value is correct, no doubt. And sea level temperature, if you go, no, this sea level temperature is wrong, because if you go sea level temperature, so in degree Celsius, if you see, it is nothing but 15 degrees Celsius. Okay, 15 degrees Celsius. And in Kelvin, if you go, it is nothing but 288.16 Kelvin, and density 1.225 kg per meter cube. So this is correct, but this option is this temperature, static temperature at sea level, it is wrong. So you can say this option C is also wrong. Okay. And option D, air is treated as perfect. Obviously air is treated as a perfect gas. That's the reason you are using this perfect gas equation. So it means option D is also correct. So what is the correct answer? Correct answer for this question is nothing but option A and option D. All right. Okay. Now we'll go for next question. This is another question. Okay. This question is nothing but 32. Again, this is the same. Whatever the question we are solving, this is for GATE 2022. Okay. And question number is nothing but 32. Okay. Now if you check, an unpowered glider, obviously glider means unpowered flight. So that's the reason gliding flight also called. You might have heard this gliding flight. This gliding flight also called as unpowered flight. Okay, unpowered flight. All right, you might be know. Unpowered flight means thrust or power will be zero. If it is jet engine, thrust, obviously jet engine means what? There is no power. It doesn't mean uh, there will not be engine. No, maybe there will be engine, but they can switch off that engine. That may also happens. Okay. So but if you say gliding uh, flight, it means thrust or power will be zero. Okay, that's the mean of it. Now, okay, we read the question. An unpowered glider is flying at a glide angle of 10 degree. Its lift to drag ratio is it is the fill in the blank question. Okay, so obviously we'll solve this problem. So glider is like, it is a descending flight. Gliding means descending flight. So it will be losing the altitude. So you have to show the flight, like this is the flight. This is the uh, flight you have to show. Okay, you can say this is the glider. All right. Now I will show this axis here. Here this is nothing but velocity v, and obviously this is the CG, so weight will be acting downward, W. All right, and perpendicular to this velocity will have a lift force. Opposite to this forward motion will have a drag, D. And thrust should be here, but it is gliding case, so thrust will be zero. That's the mean of it. All right. And from the horizontal you can say gliding angle is gamma. So what is the gamma? Gamma is nothing but gliding angle. Okay, so this is the W. If you resolve this, so component you may get this is the W here. So this will also gamma, because this is gamma, so this is also gamma. So this value will be W cos gamma. All right. Now you will solve it. What you may get? Check. L is equal to W cos gamma. And where is the W sin gamma? Check. This is W cos, so this in this direction will have a W. This is the two component, right? So what is the W sin gamma? It is nothing but drag, because drag is just opposite to W sin gamma. So this is W. All right. Now if you check, so it is nothing but solve this. So tan gamma is equal to, it is d by L. All right. What they are asking? Lift to drag ratio. You just take reverse lift to drag. So it will be 1 upon tan gamma. And that gamma value they have given in degree. So 1 upon, that value is given 1 upon 10. So L by D, this is also called aerodynamic efficiency, capital E, if you remember. Aerodynamic efficiency, it is lift to drag ratio, also called aerodynamic efficiency, L by D, which is nothing but 1 upon tan gamma. If you solve it, okay, gamma value you have now. So if you solve this, you may have 1 upon tan gamma is nothing but, you check, it is almost 0.176. If you solve this, how much you may get? You may get nearby 5 point, up to 2 decimal they have said, okay. So 5.67 I will write. This is the correct answer. Okay, 5.67 is the correct answer. So I will write here 5.67. That's all. This is the answer. I hope you understood this. All right. Now we'll go for next problem. Check. This is again, as I mentioned, for all problems I am saying this is GATE 2022, and if you go for it, this is question number 40. Okay. Now see what they have given. Consider conventional subsonic fixed wing airplane. E is the hoist wall efficiency, check it, and hoist wall efficiency factor. AR is the aspect ratio, okay, corresponding to minimum CD by CL to power 3 by 2. Which of the following relation is true? All right. Now, relations is true. Okay. Now, so you have, it is given CD CL power 3 by 2. They are saying minimum. This minimum CD by CL to power 3 by 2 minimum value will also be called as minimum. If you check my classes, okay, the subject classes also available. If you check, it was explained well how and why CD by CL to power 3 by 2 will be called as a minimum power required condition. So it was explained there in that particular uh, class. Okay, so this is the minimum power required. All right. Now obviously they are asking the ratio value here available, whatever the ratio value available here, they are asking that ratio for minimum CD by CL to power 3 by 2 or minimum power required condition. So minimum power required condition, if you write CL, see it is minimum power required, so I will write CL MP. If I say minimum drag, okay, or CD value at minimum power condition, for drag value if you write minimum power required condition, so CD value will be CD MP. So whatever the CD and CL it is given, actually it is CLMP and CDMP. All right. Now you know very well drag polar. What is the drag polar? See, drag polar, I will write one general equation. Okay. What is the general equation value? Any idea? So I will write here. It is nothing but CD naught plus KCl square, where K is the constant which is given 1 upon pi EAR. What is the E? Hoist wall efficiency factor. It is given here. Check hoist wall efficiency factor. AR is the aspect ratio. So I may break this K in terms of 1 upon pi EAR. All right. Now you know this. So if I write CL, which means CLMP, so from this drag polar CLMP minimum power required condition, what is the lift coefficient? It will be 3. This is the proof of, okay, 3 CD naught by K. It was proved in my lectures already. Root of 3 CD naught by K. And what is the CD? Obviously it will be minimum power condition CD value. So it will be 4 CD naught, or simply CL value if you keep here, then you may get 4 times of CD naught automatically. That derivation already we have done in our lectures, okay, previous lectures. So you can watch that also, not an issue. Now I'll check the CL and CD value. We have a multiple options. They have given CD by CL square, this CD by CL square, this value, CD by CL, and CD by root of CL. By the, you just use the sense here, common sense. What is the common sense? I mean, how to approach towards the correct answer? Check in your CL value, means CLMP, 3 is available, and in your CD value 4 is available. So means 3 and 4 should come in that ratio. 3 and 4 should come. If check which option, 3 and 4, so you may get this option B, number 1. Okay, anywhere 3 and 4 you are getting known. Now, so what you will do, now you will check CD by CL square, this value you are getting or not. Means 4 and 3 you are getting in this option, that is okay. That is the first cross check. Second cross check, you find the correct value and check this value is there or not. So it is nothing but CD by CL square. So I will go for CD by CL square. So CD by CL square, which means CDMP by CLMP square. So CDMP is nothing but 4 CD naught, as usual you can write, and CLMP square, so it will be, you just square it, so you may get 3 CD naught by K. If you CD naught will be cancelled out, okay, so you may get 4 by 3 K, 4 by 3, and what is the K? 1 upon pi E AR, 1 upon pi E AR, means you got CD by CL square is equal to 4 by 3 pi E AR. Check this, 4 by 3 pi E AR. So your answer, correct answer is D. Alright, hope you understood. Any doubt you may have, immediately you can message me. My number is available here, okay? So I will correct, or I will correct your doubt, whatever you have. Anytime you can ask, mail me, or you can call me, no problem. Okay, so option B, this is the option B, correct answer, okay? Now we'll go for next problem. Check, this is the next problem here. Okay, this is again, this is GATE 2022. As usual, I mentioned already, whatever the problems we are solving, it is started from GATE 2022, and problem number is 56. You can check this. All right. Now check a conventional airplane of mass M, they have given how much? 500 kg, doing a level turn of radius 100 meter. Okay, so level turn is given, and radius how much it is given? 1000 meter. Okay, constant speed. Okay, during turning, that constant speed is given V naught. It is given how much? 100 meter per second at sea level. Taking the acceleration due to gravity G, they have given. Good, meter per second square. All these value they have given to you, and what they are asking, bank angle of the airplane. This is also fill in the blank problem. So these are the problems for 2 marks. Okay, you can check the weightage of the problem. It is 2 marks. So bank angle they are asking. Okay, bank angle. So general like notation for the bank angle is what? Phi. So we'll go for the solution for this problem. Now check. We have two case we have to take. This is the aircraft condition, and this aircraft condition is what? Before turning. This is before turning condition. So if you check this is the W, and here we'll have a lift force. This is the before turning, okay, before. And we'll take another condition which is nothing but during turning condition, okay. So during turning condition, if you check, so you may have, this is the during turning, okay. We relate it, it's very simple, that also I have taught in my lectures, okay. So now this is the turning condition. So basically this is the vertical axis here. From here it is turn. So, or you can say this is the axis along the wing and this is the horizontal. So from horizontal to this axis, this angle is phi. This is called turning angle. This is called banking angle. Okay, and obviously this is phi. Obviously this will also be phi. There should not be any doubt about it. Okay. Now you will have obviously this will be lift force, as previous case you have seen. So if this is L and that weight will be acting always downward direction, so but if it is turned like this or banked like this, so L will come here in this way, this is the L now, but weight will be acting downward. So this component, vertical component, will be L cos phi, and this side here it will be L sin phi. If it is turning, then obviously this one force will may appear, which is nothing but centrifugal force mb square by r. So this, how it appears, so it's very simple, you can check in this way. This is the aircraft and this is now turned like this, okay. So you may have turning radius like this, yes or no? So you just relate these two diagrams. So if it is turning, then banking angle may appear, and that banking angle is what? Phi. Now you just resolve the forces, okay, simple. Resolve the forces. What force you may get? L cos phi is equal to W weight, which is nothing but mg, and L sin phi is equal to force. So in circular motion you have seen that centrifugal and centripetal force, mg square by r. Now you can take the ratio. How much you may get? Tan phi. What is the tan phi? Mm cancel out. You may have v square by rg. Okay. What is the phi? You may have tan v square by rg. Check all the value they have given to you. Tan inverse. What is the v? Here it is given. Check. V is 100 meter per second. R is given 1000. G is given. Mass, automatically it will be cancelled out. No need to write. So v square means 100 square divided by 1000 into 10. Okay, you solve it. R is 1000 into 10 is G. If you solve, you may get 5 tan inverse 100 square means 10 to the power 4 divided by 10 to the power 4. So you may get 1, and tan inverse 1 is nothing but 45 degree. So degree phi is nothing but banked angle, and this banked angle phi you have to write here. It is already degrees given, so you have to write only 45. That's all. Remember, you need to write in degree, okay? Because in radian that value will be changed. That value will be pi by 4. If it is radian, they have suppose given radian. So in radian it will be pi by 4. Pi by 4 radian. But what they have asked degree, so you write this 45. Okay, this is the correct answer for the particular question. I hope you all, whatever the problem we have solved here, you all understand that solution of the problem. Okay. Any doubt you may get, for any problems, you can message me. Thank you all. Thank you so much.